Rutherford, along with his assistants, H. Geiger and E. Marsden, performed the alpha particle scattering experiment, which led to the birth of the nuclear model of an atom, a major step towards how we see the atom today. They took a thin gold foil having a thickness of 2.1 times 10 to the power minus 7 meters and placed it in the center of a rotatable detector made of zinc sulfide and a microscope. Then, they directed a beam of 5.5 MeV alpha particles emitted from a radioactive source at the foil. After hitting the foil, the scattering of these alpha particles could be studied by the brief flashes on the screen. Rutherford and his team expected to learn more about the structure of the atom from the results of this experiment. Here is what they found. Most of the alpha particles passed through the foil without suffering any collisions. Around 0.14% of the incident alpha particles scattered by more than 1 degree. And around 1 in 8,000 alpha particles deflected by more than 90 degrees. These observations led to many arguments and conclusions which laid down the structure of the nuclear model on an atom. Rutherford concluded that since alpha particles are positively charged, for them to be deflected back, they needed a large repelling force. He further argued that for this to happen, the positive charge of the atom needs to be concentrated in the center. Now let's look at the gold foil closely. Although it was multi-atom thick in the experiment, we will show single layer of atoms for simplicity. According to Rutherford, most of the alpha particles pass through the gold foil because most of the volume inside the atoms is empty. When the incident alpha particle came very close to the positive mass in the center of the atom, it would repel, leading to a deflection. He then suggested the nuclear model of an atom, wherein the entire positive charge and most of the mass of the atom is concentrated in the nucleus. Also, the electrons are moving in orbits around the nucleus akin to the planets and the sun. Further, Rutherford also concluded from his experiments that the size of the nucleus is between 10 to the power minus 15 and 10 to the power minus 14 meter. This eventually implies that most of the atom is empty space and explains why most alpha particles went right through the foil. Also, the electrons having negligible mass do not affect the trajectory of these incident alpha particles.